have together on the plane. So this is practice test. Okay, test number 1. So you have a couple of questions of the plane. Should be able to find the equation of the plane. In order to find the equation of the plane, you know that you need a point, okay, and a normal vector. So this is going to be the equation of the plane. This is the equation of the plane passing through the point. So your point would be x0, y0, z0, and the directional vector is going to be a, b, normal vector, sorry. Normal vector is going to be a, b, c. So this is a vector that's going to be perpendicular to anything inside the plane. Anything inside the plane. So don't miss it. For example, the question number 2 is of this category. You want to find the equation of the plane with the given information. Just substitute, simplify, you're done. Okay. So just remind you how we're going to write the final answer for us so that you're not going to lose any points. Okay. So in question number 2, you have a point. Okay, so the point is given to you, it's going to be 1, 6, 6. We're going to call it x0, y0, z0, and you have a normal vector. Okay, so you call it n, they call it v, you call it n. It's a 3, 6, 3, and this is going to be considered your a, b, and c. Just substitute, simplify. Okay, this is your formula. So that's going to be a, which is 3 times x minus x0, x minus 1. Plus b, which is going to be 6 times y minus y0, which is 6. Okay, plus c, which is 3 times x minus z0, which is going to be 6, equal to the 0. And you're not done. Some people, they don't continue. You lose point. You have to simplify it. Okay, multiply, go forward. 3x minus 3, then 6y minus 36, then the 3x minus 18, equal to this. Simplify, you get the 3x, 6y. Sorry, this last one is z. Okay, so we get the 3x plus 6y plus 3z, and then you simplify the leftover. Okay, this is it. You get the negative 36 and negative 18. It's going to be 54, 57 minus 57 equal to the 0, and you're done. It's coincidence that it can be simplified by 3, that's optional. Okay, it's not going to be the case all the time, but if it is, you don't have to simplify it, okay? But this is going to be the case. So this is going to be 19 equal to the 0, that give you the equation of the plane. Okay, make sure to give us the final answer in this form to get the full grade. Okay, that's the one. Any question? Now, more popular one is number 3. You must know this one. Okay, 3 points would be given. Would like to find find the equation of the plane that's containing these 3 points. Okay, the 3 points formula, we did it previously for finding, you know, those. Okay, we talk about the area of a triangle. Remember, that was one, but you know, it's going to be either the other one or this one. So 3 points are given. We would like to find the equation of the plane passing through these 3 points. You label it as a P1, -3, -1, -13. Okay, P2 is going to be equal to the 5, B3. Okay, 5, 3, 3, and you have a -2, 0, and -2. So we call this one P3. Want to find the equation of the plane passing through this, you need a point and normal vector. In order to get the normal vector, the way we are going to use it, we are going to use the cross product. So that's going to be your P1, P2, P3. Okay, so you make 2 vectors, P1, P3 plus P1, P2. So this is the one that you're going to call it your normal vector. We're going to talk about it. You know that the cross product is going to be a vector that's going to be perpendicular to the given one. So this is going to be the one, and your point P is going to be -3, -1, -30. Okay, so create the P1, P3. They are point to make it into the vector P1, P3. The difference between 1 and 3. So it's going to be -2 plus 3. Okay, 0 plus 1, and then -12 plus 13. You know that you subtract the components to get it. So we simplify it. So that give you 1, 1, and 1. Okay, so that's going to be 1, 1, 1. There you are. And the other one is P1, P2. So it's going to be difference between 1 and 2, 1 and 2. So that give you 5 plus 3, 3 plus 1, and the 3 plus 13. So you arrive at 8, 4, and 60. Now the cross product, you know, there's going to be determinant of a matrix. So N, the normal that you are interested in, is going to be the determinant of this matrix, I, J, K. So the first one is 1, 1, 1, and the second one is going to be, okay, the second one is 8, 4, 8, 4, and 60. So we get this one, then you're done. Okay, I times, you eliminate, you know, the first row, first column, the matrix, 1, 1, 4, 16, plus multiply, that give you 16 minus 4. Okay, minus J, the matrix, eliminate the first row, second column, 1, 1, 8, 16. So it's going to be 16 minus 8. Then we get a K, eliminate the first one, last column. So it's going to be 4 minus 8. So your vector is going to be, that's a 12I minus 8J and the minus 2K. So it's a 12, -8, and -2. Okay, that is going to be, that's going to be the case. Then you are going to put it into the, okay, -12, 8, and okay, that's the one. So this is going to be 1, and the point is -3, -1, -13. So this is going to be your x0, y0, z0. Okay, equation of the plane. So this is going to be your ABC. ABC. Go ahead and write the equation. Okay, it's going to be A, which is 12. 12 times x minus x0, which is a +3. B minus 8 times y minus y0, which is a +1. C -2 times z minus, okay, z0, which is going to be a +13, equal to this. Again, you're not done. You have to simplify it. So it's going to be 12x 36 minus 8y minus 8 minus 2z minus 26 equal to this. So this is it. It's going to be 12x minus 8y and minus 2z. Simplify the numbers. Okay, 36, 26, that we have +10, and 2. This is going to be the equation of the plane. All of them are divisible by 2. So the 6x minus 4y minus z plus 1 equal to the 0. This would be the equation of the plane. Okay, you don't have to simplify it, but if you get a chance, you better do it. Okay, so pay attention to this this one. Then you have a question that you want to compare a line and a plane together. Okay, anything you want to compare, you know that you have to bring the normal line. Bring the normal line and you compare with the directional vector. Okay, normal vector, directional vector. You compare those together to find out whether they are going to be parallel or perpendicular. Okay. What's that? Would a vector that has inverse signs still to be perpendicular? What do you mean by inverse sign? By the inverse sign, you mean the opposite? If you mean opposite, yes, that's going to be the case. Yeah. Yeah, you multiply all of them by -1. Yes, that is the answer. Yes. Okay, so this is it. Just give me 1 minute. Open this door. So I have to go. So they usually give you one question to compare, and some people they miss this one. Okay, so let's get through this number one to explain it. These are the group of lines and planes, and you want to compare them together to see whether they're going to be parallel or perpendicular. So find the normal vector and the directional vector, and then guess what is going on. Okay, so this is going to be the case. So one short one would be good too. Okay, this is number one. A comparison between this group. You see the first one. The first one, you have the line is x plus y equal to the -t. And the z equal to the -1 minus 4t. So get the directional vector. Remember, this is x0, y0, z0 directional vector. V is equal to what? Its coefficient. It's going to be 2, -1, 2, -1, -4. This is your directional vector for the line. Now plane. In the case of the plane, you have the 3x plus 2y plus z, okay, minus 7 equal to the z. So the normal vector, this is the normal vector. The normal vector is going to be 3, 2, and 1. This is the one that you're going to have. Okay, you compare these two together. If these two they are not going to be parallel, these two lines, two vectors, you know that. If it's going to be parallel, one of them is going to be what? One of them is going to be a scalar multiple of the other one. So check the dot product to see if the dot product are going to be the same. It's going to be 0. If you get the dot product, so that gives you 2 times 3 plus -1 times 2, okay, plus -4 times 1. So that gives you 6 minus 2 minus 4. The dot product would be 0. So n dot v is equal to the 0. So what does it mean? This means the vector v is going to be perpendicular. It's going to be orthogonal to n. Just think about it. You see this is the plane. This is the plane that you have. Okay, this is the plane that you have, and this is going to be your. Okay, this is going to be your normal vector. So this vector is going to be perpendicular to the normal. If it's going to be perpendicular to the normal, so this vector is going to be parallel to the plane. Okay, that's the one. So they are orthogonal to each other. So the blue one is going to be your directional vector. So since the dot product is 0, so this means the line and the plane, both of them are going to be parallel. Okay. So the line and the plane. Okay, if they are going to be If they are going to be parallel to each other, then in that case, the line and the plane are going to be perpendicular to each other. You see, if they're going to be parallel, this is what they hit. So both of them are going to be perpendicular to the plane. So this is the way you compare it. Okay, that's part B. Part A. Any question? Checking part B. Because we have quite a lot, so we give you one. So you have to compare it. X is -1 plus, part B. X is equal to t, y is equal to 2t, and the z is equal to the 3t. Okay, get the directional vector. So the directional vector coefficient of the t, 1, 2, 3. That's directional vector. Get the plane. The plane is x minus y plus 2z equal to the 5. So the normal vector is going to be the coefficient of the x, y, z, which is 1, -1, and 2. Okay, so they are not parallel, because for the parallel, one must be a scalar multiple of the other one. Check to see if they are orthogonal. So check n dot b. It's going to be 1 times 1, -1 times 2, and the 2 times 3. So that gives you 1 minus 2 plus 6. So this would be, okay, this would be 5. This would be 5 is not equal to the 0, so it's neither. Because they are not parallel to each other and they are not orthogonal to each other, okay? So the answer to this one would be neither or neither. So this is the one. Question. Checking part C to see if the normal vector and the and directional vector are going to be parallel to each other. Checking C, x equal to the 1 plus 2t, y equal to the 4 plus t, and the z equal to the 1 minus t. Get the directional vector. The directional vector would be what? Coefficient of the t, 2, 1, -1. That's the directional vector. Get the plane. The plane is 4x plus 2y. 4x plus 2y minus 2z equal to the 7. Coefficient of the x, y, z is going to be your normal line. So the coefficient is going to be 4, 2, -2. As you can see, this is twice of the v. Okay, if you pull out the 2, so that give you 2, 1, -1. So this means this is twice of the v. So this means this vector is going to be parallel to the, parallel to the v. When it's parallel to the v, this means it's like v and n are like each other. And you know that this means v is also orthogonal. So this means the line and the plane are perpendicular to each other. Okay? Because the meaning of the normal line means orthogonal. So since they are parallel, they are like each other. So the v, which is going to be your line, is going to be orthogonal to it's the other way around when they operate. Okay? So the line, okay, there you are. So the line and the plane are going to be orthogonal. So make sure that you don't miss it. It's a very easy question, but you can easily miss it. Let me describe. Okay, so there's another question on the plane. You have number 4, okay, a couple of more. You can check it yourself. But make sure that you bring the distance formula, because that's that's the concept that we check. So we usually give you one question on that. Okay. So there are 2 possibilities. Bring both formulas. Easy question. Don't miss it. Okay. So that would be question number 5 and 6. Make sure you have your distance formulas available. The distance formula is going to be the first one is the distance of a point outside of the plane. Okay, so the first one is going to be distance between, okay, between a point and a plane. So this is the formula. Distance is absolute value of, and the point would have the coordinate, okay, x0, y0, and then you substitute, give you ax0, by0, c is z0, plus a d. It's like substitute x, y, plug in the points into the plane. And that would be divided by a squared plus b squared plus c squared. So this is where this is the point, x0, y0, z0, and this is the plane. See? Make sure that your equation of the plane is of this part. If the constant term is other side of the equation, move it to the left. Okay? So that's one. The other one is going to be distance between two planes. The planes are parallel. Distance, okay, between two parallel planes. So you know that the parallel planes would have the same normal vector. The only difference is going to be d, the constant term. So that would be easy formula. So the top is the difference between the d's, okay, d1 and the d2. The bottom one would be x squared, a squared, b squared, c squared. Because the ABC would be the same. A would be the same in both planes. If they are not the same, you may have to divide by a number or something to make it equal. Then you pick the D1 and the D2 and just substitute it. Okay, don't miss it. It's a very easy question. I'll give you one. So these two usually would form one question for the test. Okay, comparison and just one of these distance formula. So make sure your formulas are available. So let me just check to make sure you know the you are going to substitute. Any question? Add these two to your collection. Okay, for your now. And this is 5 and 6. Okay, so in the case of the 5, you have a point. It's going to be a point P, which is 1, 2, 3. You call it x0, y0, z0. Okay, and you have a plane. So you have a plane in this equation, 5x plus 8y plus 7z equal to 14. And distance for the distance is missing. The first thing to do, you have to move the 14 to the left. Yes.
Is the 8y negative?
Which one? This one?
Yes, for part 5. On the PDF, it says 5x minus 8y.
Yeah.
Okay.
Very good. Okay, there you are. You have to move the 14 to the left for operating. Okay, because in the formula, it's equal to the 0. So make sure you do it. So we change this on pairs. It's a 5x minus 8y plus 7z minus 14 equal to this. Now it's ready. So we go with the distance formula, distance of absolute value, 5 times x0. 5 times x0 is 1. Minus 8 times y0, it's 2. 7 times z0, it's 3. And the d, minus 14. Okay, divided by a squared plus b squared, that's it. It's a 5 squared, negative 8 squared, and a 7 squared. That's the way you know you substitute. So simplify the top. Inside, that gives you 5, 16, 21 minus 14. Bottom, 25. 64, 49. Simplify, give us the answer. Okay, that's it, the top. So that would be negative 11, okay, negative 11, that give you a positive 10, okay, negative 4. And down the bottom over here, okay, we have 25 and 64. That would be 69, 89, 89 and 49. Okay, so that would be like 90 and 48. I think it's a 138, yeah. It's just, yeah, it's going to be square root of 130, 138. I think that's what. Okay. So that give you 4 over, it's a 4 over the square root of 138 and with that. Okay, just make sure, just use the proper formula. Okay, any questions? That's a number 5, distance between the point and the plane. Checking number 6. Okay, checking number 6, distance between 2 parallel planes. So make sure that everything is ready. The first plane is 7x minus 4y plus 2z minus 5 equal to the 0. The second one is 14x minus 8y plus 4z minus 16 equal to the 0, and the d is missing. Check to make sure that it's ready. It's ready when the normal vectors are the same. It's not ready yet because this is 7, 4, 2, and that's a 14, 8, 4. So you have to divide this one by 2 to make them equal to each other first, then do the distance. Otherwise, your solution would be different. Okay, so make sure you do it. So over here, divide by 2 first. So you make it to the 7x minus 4y plus 2z minus 8 equal to this. Now pick the normal vector. So the normal vector is going to be 7, negative 4, and 2. It's a normal vector. D1 and D2, you get the negative 5 and negative 8. Okay, D1 of a negative 5 and the D2 of a negative 8. Okay, make sure it's in the standard form. Now we are ready. Distance between 2 parallel planes, D1 minus D2, and the square root of a squared plus b squared plus c squared. Substitute. So that gives me negative 5 minus negative 8. And this is going to be the square root of 7 squared, negative 4 squared, and the 2 squared. See it, simplify. So on the top, that give you is equal to the negative 5 plus 8. Down the bottom, the square root of 49, 16, and 4. Okay, the top would be 3. You don't need any absolute value. And the bottom one would be 20, 69. So that give you the distance. Can do that. Okay, this is all we are interested in. And one more problem regarding the angle between those planes. We are not going to be interested in those type. So just make sure this is the one you need to know from the planes. Okay, so 2 questions on the plane. This is what we're writing the equation. Okay, put them together. Don't miss it. Okay, so that is the leftover from your quiz regarding these functions. The rest are going to be, to give you something like 7 questions on the vector value function. Okay, the domain, the limit, the derivative, limit, the derivative, no continuity. The derivatives and application of the derivative, which means R of t is a position function. So R prime is going to be velocity. R double prime would be acceleration. In the meantime, you have to take care of the speed, which is the norm of the velocity, norm of the v prime of t. This is one or the other way around. The other way around means one of these would be given, then you have to recover the function. Okay, it's like indefinite integral. And then, integrations, straightforward, be patient. It's going to be messy, the integral that you're going to have, and eventually arc length and the, arc length and the, what's that, curvature. Okay, we can try one from each to go through it. Okay, again, be patient. The operations number 7. Okay, there we are. Vector valued function. Vector valued function. This is what you have to know. First one, domain. A domain, and that is number 7. Number 7. You know that's going to be, you have to work on the components. So in number 7, the function is R of t equal to t to the 8. It's a radical t minus 1. The last component is 9 minus t. We get the R real valued function, the component, you find the domain of each, then you're going to get the common ground, okay? So that's it. The first one, nothing to worry about. It's going to be negative infinity, positive infinity. The second one, restriction is t greater than or equal to the 1. So this means 1 and positive infinity. And the last one, okay, 9 minus t must be greater than or equal to 0. Okay, 9 minus t greater than or equal to 0. Give you t less than or equal to 9. So it's a negative infinity to 9. So you have to find the intersection. You don't have to worry about the first one because it's all number line. So you have to find the common ground between these two. Okay, you can put it on the number line if you need. So that's a negative infinity, positive infinity. Check these two, 1 and infinity. This is 1 and positive infinity. That is one version. And then negative infinity and 9. So this is 9, negative infinity and 9. We get the intersection between these two groups. As you can see, it's going to be between 1 and 9. Okay, so the domain of the function is going to be 1 and 9. Okay, double check, make sure that I get it right. So I didn't bother about that negative infinity, positive infinity because I want a common ground. Okay, any question? So that is going to be the case. Give you one. You have another one in number 8. Ask for some other things, but they ask the domain first. Number 8. Number 8, the function is this one, R of t equal to the square root of 2 minus t. The second part, e to the t minus 1 over t. And the last part is ln of the t plus 1. Two vectors. Okay, check each section one by one. So this is the restriction is 2 minus t greater than or equal to 0. So that gives you t less than or equal to 2. So it's a negative infinity to 2. That's first one. Second one, only t not equal to 0. Okay, that's easy. The last one is ln function, L plus 1 to be greater than 0. So t greater than negative 1. So it's going to be negative 1 and positive infinity, but 1 is not included. Middle one can be taken care of quickly, so take care of the others. So it's a negative infinity to positive infinity. And this is 0. We're going to take the 0 out. because t cannot be equal to 0. Okay. Now you have negative infinity to positive 2. This is negative infinity, positive 2, 1, 2. So that would be one version. Okay. Then the other one is the negative 1 and positive infinity. So that's going to be negative 1. Negative 1 is not included. And positive infinity. This is going to be a positive infinity. Okay, so as you can see, the colorful one is going to be between these two. It's going to be between 1 and 2, but you've got to be careful because the 0 is excluded. So it's going to be two portions, one portion over here, and this is going to be the second portion. Okay, you have to break it because the 0 is not given to you. So the domain is going to be, you start with the 1, go to the 0. You don't have the 0, you don't have the 1. Okay, union with 0 and 2. You don't have the 0, but you do have the 2. So that gives you the domain of the function. Any question? So be careful when you put them together, especially the end point of the interval is important. Any question? So that is the domain. In this part, they ask for the limit of R of t. We give these separately, but in this problem, all of them are given to you. So that's a part 1 of the number 8. So in part 2, you want to find the limit of the R of t. So the limit of R of t, when t goes to 0, you know that you take the limit inside each factor and just do it. You can do it separately or just do it right away. So you have to find the limit of the radical 2 minus t, t goes to 0. It's going to be radical 2. You have to find the limit of e to the t minus 1 over t, t goes to 0. You have to work on this one. And the last one is the limit of the ln of t plus 1. T goes to 0. Okay, so the first one is easy, that give a radical 2. As t goes to 0, it's a continuous function. The last one is 0, c, so that give you ln 1, which is equal to the 0. You have to take care of this one, because that would be 0, 0. Okay, you have to use the L'Hopital rule. So I take care of this, limit of e to the t minus 1 over t, t goes to 0. So that would be e to the 0 minus 1 over 0, which is 1 minus 1, 0, 0. So we have to use the L'Hopital rule. You remember the limit of the derivative of the top and the bottom. So we go with the L'Hopital rule or L'Hopital rule. So the limit would be t goes to 0. Derivative of the top, derivative of e to the t is just e to the t. Derivative of 1, 0. Derivative of t is 1. So that gives e to the 0, which is equal to 1. So the result is a vector. So what's going to be the result? Limit of r of t, t goes to 0, is vector radical 2, 1 and 0. So this would be the final answer. Okay, make sure you remember that you're dealing with the, you're dealing with the vector valued function. Dealing with the vector valued function, so the result must be a vector when you write it down. So probably in the limit that is given to you on the test, you need to apply the L'Hopital rule. So be ready for it. Ln t over t to the t over t. These are the ones that we use. Tangent inverse, even it goes to infinity, this type of argument. So make sure you know. Okay, so this is the part B of this question. Any question? Part C, they ask for the derivatives, so differentiate each one of them. Okay. But these separate this question into the different categories. So 8C is straightforward. We want to find the R prime of t. So you have to differentiate the function that you have. Remember, I just take them out and explain it. The first component is 2 minus t. You want to differentiate it, you have to rewrite it. Then apply the chain rule. So x prime of t would be 1/2 2 minus t to the negative 1/2 times u prime, which is a negative 1. Okay, just apply the chain rule. So this is going to be, okay, it's going to be just a negative 1/2 2 minus t to the negative 1. This is the first one, the first component. Okay, second component, y of t equal to the e to the t minus 1 over t. You have to use the quotient rule. Lift up the top, bottom, bottom, top, and simplify it. So y prime of t is going to be equal to the lift of the top, e to the t, times the bottom, just t, minus the lift of the bottom is 1 times top, divided by the bottom square. Okay, distribute it, simplified if you can. Y prime of t would be t e to the t minus e to the t plus 1 t squared. We cannot simplify it. So that's going to be the second component. Okay, and the last component. The last component is ln of a t plus 1. You know, derivative of a natural log, u prime u, 1 over t plus 1. So you declare the solution. R prime of t again is a vector. It's a vector, the first component, negative 1/2 2 minus t to the negative 1/2. The second component is a t e to the t minus e to the t plus 1 over t squared. And the last one is 1 over t plus 1. Okay, so be patient, you know. It's not the thing that you need, you know, like to have something nice, but you know, differentiate it. You don't have to simplify it. You can't do anything else. Okay, so expect to have one of these differentiation. Any question? Now, the big one, the one that you have to be careful about is unit tangent vector and the unit normal vector. Okay, this is going to be the case. We give you one. As I talk about it, we need this one for the end of the course. You see it now, and then you are going to get back to it later on. So that's question number 9. So it's going to be one question, 2 parts: normal vector, unit tangent vector, unit normal vector. Okay, that's it. So you have R of t is equal to the 1/3 of t cubed, 1/2 of the t squared and t. You want to find the unit vector at t equal to 1 and the normal vector at t equal to 1. So you want to find the t of t and the n of t. See it? Have to find t of t first. You know that t of t is just a tangent vector, which is normal. Tangent vector is derivative, r prime of t over norm of the r prime of t. This is unit normal vector. Unit tangent vector. Okay. For the normal vector, you have to find the t prime of t and normalize it. Okay. So that would take more time. N of t would be t prime is going to be normal vector, but you normalize it, get the unit vector. Okay, that's your job. You wanted that t1. But you have to get the differentiation first and come. Okay, carefully differentiate it. The one that you have is not bad. It's easy and short. We go for it. You find r prime of t first. R prime of t. You differentiate it. You bring the 3 times 1/3 would be 1 t squared. Second one would be t, and the last one would be 1. This is going to be your r prime. You keep it. Okay, since so far you wanted at 1, so we can replace the t by 1 to find it, to get to the normal vector at 1 first. But eventually you have to find the t of t because you want to differentiate it. Okay, so we have to go on. So we find the norm of the r prime of t, which is going to be sum of the squares. Okay, so that give you t squared, and the t squared and the 1. So that give you t to the 4th plus t squared plus 1. This is going to be your norm. Okay. So you want to, you can get it at 1 to talk about the normal, but we have to come back to it again. Okay. So there you are. R prime at 1 is going to be 1, 1, 1. And the norm of the r prime at 1 is simply, the square root of this 1, 1, 1 would be radical 3. So the normal, the tangent vector at 1 is going to be, this is it, it's going to be r prime of t, r prime of 1 divided by radical 3, which is the same as 1 over radical 3, r prime of 1 as a vector. So as a vector is 1, 1, so 1 over radical 3, 1, 1, 1. So your unit tangent vector at 1 would be 1 over radical 3, 1 over radical 3, and 1 over that. We don't have to rationalize. This would be the unit normal vector at 1. Unit tangent. Okay, if there is going to be something with the sine, cosine, that's easy. You'll be able to simplify it. But not this one. Now, the big one is we have to go for the normal. In order to get the normal, you see you need t prime of t. This is your, you have to get the t of t first. Okay, then good luck, differentiate it. So again, they give you something easier to handle. Okay, are you done with this? So what I'm going to do, I'm going to find the t of t in these. Okay, this is r prime of t, t squared t1, and the bottom one is this one that we have to differentiate it using the product rule or the quotient rule. Okay, so the next part is going to be, we are focusing on finding n of t. So we need t prime of t first. T prime of t is t of t, sorry. T of t is going to be r prime of t over the norm of the r prime of t. So this is going to be equal to, okay, r prime of t, we differentiated, that's a t squared, that's a vector, t squared, t1. And the norm is t to the 4th, t squared and 1. It's the one, we want to differentiate this one. So we have to decide how we're going to handle it. Okay, so one way to do it is just to move it up. It's going to be t to the 4th plus t squared plus 1 to the half times it by this vector, which is a t squared t1. You can take it inside and differentiate it, or you can, it's a negative 1. Or you can apply the, okay, apply the product rule. That maybe that's easier. Then simplify that one to get the result. Okay. That's it. I'm going to differentiate it using the product rule. So t prime of t is going to be derivative of the first, second, first. The first one, chain rule, -1/2 t to the 4th plus t squared plus 1, okay, to the -3/2 times u prime, which is 4t cubed plus 2t. That's the derivative of the first. Times it by the second, t squared, t1. Okay, that's it. Plus, you have to have a second times first. So I do the first as is times the second is a vector. So that gives you 2t, 1 and 0. So that would be t prime of t. Any question? Since you want to find the normal at 1, you better replace t by 1 now, because that would be easier. Okay, because they ask for the normal vector at t equal to 1. So I'm going to find t prime of 1. Then I simplify. T prime of 1, negative 1 half. 1, 1, 1. Make it 3. So that's going to be 3 to the negative 3 half. Times it by 4 and 2. 6. Okay, times it by 1, 1, 1. Then plus inside it's a 3 to the negative half. And that could be 2, 1, 0. Okay, I replace the t by 1. Simplify it as much as you can and then get the norm. So these two will cancel out. So you arrive at the negative 3 to the negative 3 half times 3. And you can simplify it. So it's going to be 1, 1, 1. And over here, I cannot do much about it. So I write this one as 1 over radical 3 to simplify it. Okay, that's it. This is 3 to the negative 1.5. And this is 3 to the first. Okay, negative 1.5 plus 1 will be negative half. So that gives me negative 3 to the negative half times 1, 1, 1, and plus 1 over radical 3, and that gives you 2, 1, 0. Okay, so that would be negative 1 over radical 3, and that's a 1, 1, 1, and this is going to be 1 over radical 3, and that gives you 2, 1, 0. That's it. You can multiply inside or you can factor it, then put them together. Depends which one you prefer. Okay, I prefer to take out the 1/3 out. So the first vector here is a negative 1, negative 1, negative 1. And the second one is going to be 2, 1, 0. Okay, so that gives me 1 over radical 3 and the vector now. Negative 1 plus 2, that gives you 1. That gives you 0. And that gives you negative 1. Okay, so this is t prime of 1. Now I can put it inside. It's going to be 1 over radical 3, 0, and negative 1 over radical 3. So that is normal vector. Okay, that is the normal vector. So I have to normalize it to get the unit vector. Okay, I need the norm. So I find the norm of the t prime of 1 is going to be the square root of the square of these. 1 over radical 3 squared. That's 0 plus negative 1 over radical 3 squared. So that gives you, you square this one, you get a third is and a third. So that gives you 2/3. Okay. That would be 2/3. You can write down as, I think that's correct. So you can write down as a radical 2 over radical 3, whatever you like. Okay, because you have to get a number out of these. This is going to be the 1, or it's going to be 3 radical 2 over. Sorry, it's going to be radical 3 times radical 2 divided by 3, or the radical 6 3. Okay, I don't know whether what I did on that, the one that I post for you, but it is it's almost the same. Okay, I have it at T1, which is correct. Okay, yeah, that's one, it would be simplified. So this is it, normalize it. So what is going to be n of t? N of 1 is going to be, this is it, t prime at 1 divided by the norm of the t prime of 1. So this is going to be the case. T prime of 1. Okay, this is T prime of 1 is this vector, 1 over radical 3, 0, and negative 1 over radical 3. And the bottom one is this, is a radical 6 over 3. If you didn't simplify that, would be better. You can take care of it, but it's okay. You have to use the reciprocal and put it up there to be able to get these numbers. Okay, just want to make sure I didn't make any mistake. Okay, if you keep it as a radical 2 over radical 3, that would be better. Okay, radical 2 over radical 3. Quickly, all those radical 3 will disappear, and you get the numbers right. Okay, and this is it. So the radical 3 would be disappear, so the top would be 1, 0, negative 1. The bottom one would be radical 2. So finally, this is the normal vector. 1 over radical 2, 0, and negative 1 over radical 2. Okay, that's about it. But we give you something easier. I just wanted to see, to show you what would happen really if you have to do it for all those. So when, it's going to be something like the helix, because you get those symmetric form of sine square, cosine square would be equal to 1. It can be done, okay? So the one that you have on the test is straightforward. And nothing to worry about it, because when we are going to apply it in future for the method of integration, this situation would be different, because these are only vectors. The objects that we're going to apply these to are going to be functions. So in that case, the situation is going to be easier to handle. It's really quite a nice application. Just wait for it at the end of the course. But this is physics, okay? This is logical. Okay, so be ready for it. One question, make your formulas are all ready to find the unit tangent vector and the unit normal vector. Both of them together as one question. Okay, and that's it. That's a good one. You can do it. So this is going to be the situation. Now, the other one that we are going to have is going to be, so that was question number 9. Question number 10, remember we talked about the various, we talk about the tangent vector, normal vector, they are all vector. But for the tangent line, okay, we can give you the parametric equation of a tangent line. Okay, so this problem number 10 is going to be of this format. So a function is given to you, you want to find the equation of a tangent line, basically. In order to get the equation of the line, you know that you need a point and the kind of the slope, direction. The direction is going to be r prime. So you differentiate like in calculus 1. You find the derivative of the function, but the result is a vector. So you drop the point into the function, you get a point, okay, because a t would be given to you. Then you differentiate it, you substitute that, give you a directional vector. Then you put them together, give us the parametric equation of the tangent line. Okay, so this would be easy question. I gave this one once on the test. Most of the people, they missed it. They didn't get it that this is different from it's same thing, but it's different from the unit tangent vector or the normal vector. It's simply a line. You want to write the equation of the line, you need a point and the directional vector. It's a tangent line, the direction is going to be r prime. Okay, so in that case, it's going to be easy question. So I'm going to explain it. Number 10. Okay, number 10, find the vector equation of the line. So this is number 10. Vector equation, you see, is this. We call it L of t, vector, a point and the direction. So the point is going to be r of t0, direction t times r prime of t0. You see, that is going to be vector equation of we call it parametric equation of the line. If you want to write it down as one equation, if you break it out That's the one that you did. X equal to the x0 plus at, y equal to the y0 plus bt, z equal to the z0 plus zt. Okay, it's the same thing. Okay, so what you have now, for example, part one. The part one, the function is this one. R of t equal to, R of t is equal to the 2t minus 1 I plus radical, okay, that's a plus radical 3t plus 4j. That's it, it's a two-dimensional, and the point is -1 and 2. But even you can do the point right away. Okay, this is it, -1 and 2. To get this number, you have to guess to see for which value of t you will get 1 and 2, because you need it, the t0 here. Okay, so note that this is it. Can you guess what is going to be the, you see the point is -1 and 2. This is going to be what? It's going to be the same as x and the y. Okay, so if you get the x and the y as a vector, so it's a 2t minus 1 and the radical 3t plus 4. Can you guess what's t? Or you can find what is 2t minus 1 would be -1. So in that case, t would be 0. You check in the second one to make sure it's true. T equal to 0, radical 4 would be 2. Okay, so there you are. So what's going to be our equation? It's going to be r of 0 plus t times r prime of 0. Yes, get this? R of 0. R of 0 into the function. Substitute here, so that gives you 0 minus 1 times I plus, okay, this is it, 0 plus 4. That gives you the same point here, of course. Okay, just confirm it. So that gives you -I plus 2j, which is the same as the point that you have. Okay, that's a confirmation. Differentiate r prime. R prime of t. This is it, r prime of 0, in fact. So to get the r prime, you have to differentiate this. Okay, derivative of 2t minus 1 would be 2. You have to differentiate this one. Okay, so I break it to differentiate it. That's a 2t minus 1. So x prime of t would be just 2. So y of t is radical 3t plus 4, which is 3t plus 4 to the half. Differentiate it using the chain rule. So y prime of t would be what? 1/2. 3t plus 4 to the -1/2 times u prime, which is 3. So that gives you 3/2. 3/2 of the 3t plus 4. -1/2. Okay, but you want it at 0. So find it at 0. X prime of 0 would be just 2. Y prime of 0 would be what? It's a 3/2. 0 plus 4 to the -1/2. So that gives you 3/2. 4 to the 1/2 would be 2, so it's a 1. So that gives you 3/4. Okay, so r prime of 0 is what? It's 2 3/4. That's it. So this is going to be the vector, and -1 and 2 is the point. Go back and write it down. So equation L of t, R of 0 plus t times r prime of 0. Write it down in vector form. Vector form, this point would be -1 and 2, and the t and this is going to be 2 3/4. It's done. If you like, you can put them together. It's a -1 plus 2t, the x coordinate, 2 plus 3/4 of t is the y coordinate. Okay, it's nothing new because this is x0 plus at, and this is y0 plus b. Okay, so a point and a vector is given to you, just want to know. For the second one, it's the same, you can check the solution. Okay, I can give a break. We come back and we go to the function. Limit, integral, arc length, and the curvature. Okay, so let's get the notes. Now, we are going to give you one question, easy question, regarding the relationship between this moving object. We see R of t is going to be just the position of the moving object. Then finding is velocity, acceleration. Okay, so don't miss it. It's going to be a straightforward problem because there is one section of your book. So this is it. Question number 11. Number 11 is going to be the direct one. Okay, and indirect one is going to be, we should have one more. And should be 11. Let's see. So position function should be one that R prime is given to, and we want to find it. Okay, I can't see it here, but you can check your lecture notes. That one is to be, yeah. You see, if R prime is given to you, now that you can recover the R of t. You integrate, you come back. I'll give you one example. Okay, but this direct one, like number 11, and you have another one, like a number 17. So the position of the object is given to you, R of t, and they ask for ask for the velocity. Velocity is the derivative, R prime of t. Then they ask for the speed. The speed is going to be norm of the velocity, norm of the R prime of t. And then acceleration is going to be the second derivative. Okay, so don't miss it. This would be very easy question. Okay, so let me explain this one to make sure we have our formulas ready. So this is question number 11. Okay, in question number 11, R of t is a position function. Okay, position function. R prime of t, which is equal to the v of t, is is velocity function. Velocity function. And if you differentiate it again, so acceleration, a of t. It's going to be v prime of t, which is the same as r double prime of t. So this is going to be, okay, this is going to be your acceleration. Acceleration function. Okay, then in the meantime, you have the speed s of t. S of t is going to be norm of the r prime of t, or the v. So it's going to be a speed function. Speed function. Okay, so there are kind of two different questions on this one. And the first one is just r of t is given to you. You want to find these quantities, all of them together. So this is r of t, t ln t times I plus t times j, okay, and e to the negative tk. So that's straightforward. You just differentiate and just list whatever they like or you've been asked to. Okay, so we go with the speed. We go with the velocity, which is r prime of t. Differentiate. For the first one, you have to use the product rule. The lift of the first, second, first. So the lift of the first one, so it's going to be ln t, plus the lift of the second one, 1 over t times t. You can do it separately. Just do it as is. The lift of t is 1, so that gives you j. Lift of e to the negative t is going to be negative e to the negative tk. Okay, you simplify these two together. So velocity function is going to be ln of t plus 1 and I plus j minus e to the negative tk. So this would be velocity function. They usually ask it for some value of t. In this case, it's a general. Okay, you find the norm of the vt that give you a speed. So the speed is going to be norm of the v of t or r prime of t. So in this case, we just rewrite it. It's ln of t plus 1 all squared. Okay, plus 1 squared and plus negative e to the t squared. Okay, if you just simplify. So it's going to be L of t plus 1 all squared. This is 1, and you square this one, then give e to the negative 2t. It would be enough for this one. Okay. So that's the velocity, that's the speed. So if you want to find the acceleration, you have to differentiate v of t. So to get the acceleration, you have to differentiate the velocity. Okay, it would be easy. The lift of ln t is 1 over t times I. Lift of j, quotient is 1, coefficient is 1, so it's going to be 0. So 0 times j, and that will give you plus e to the negative 2k. So the acceleration function is going to be, okay, if you want to keep it as is, it's going to be 1 over ti plus e to the negative tk. Okay, so that's a direct problem. When everything is given to you, and they ask for it. Okay, so this is one version. The other version of this problem is problem number 16 and 17. They ask for the, okay, especially number 16. They ask to find out at what time the speed is a minimum. That's again a popular problem. We usually put all of them together as one question. Okay, this is the way usually ask. Okay, so it's a number 16. We want to find the minimum. Okay, minimum speed. This is it. So there's an algebra involved that you want to make sure that you know how to follow it. Okay, so the position is this one. R of t is 7t squared. 7t and the 7t squared minus 140t. That's a position function, and you want to find for what value of t a speed is a minimum. Okay, so we want to know when the speed is going to be a minimum. This is the problem. So we have to find a speed function first. When you find a speed function, it's just a real value function. Okay, then you can differentiate it to find out where this function or when this function would have the minimum. Okay, so find out the r prime to get the velocity first. Okay, r prime of t, carefully differentiate. That give you 14t, 7, and that give you 14t minus 140. This is your velocity, r prime. Get the norm to make it speed. So s of t, the speed, is the norm of the r prime of t. So it's going to be the square root of. So that give you 14t squared plus 7 squared plus 14t minus 140 squared. You have to simplify it because you want to minimize it. Okay, so this is just put these numbers together. You have to square the 14. Okay, I need those numbers. Okay, so this is going to be the situation we have. S of t is going to be 14 squared would be 196, so 196t squared, and this is going to be 49. Then the square of the binomial carefully, square of the first, that give you 196t squared. Then twice of the first time second. So it's going to be minus, it's going to be 2 times 196. Okay, 14 times 2 times first times second. So that gives you 3,920t. And it's going to be plus the square of the second one. It's a big number. 19600. Okay, check this with your calculator. Just make sure you square this. The result is going to be 3 terms, not just 2 terms. A square of the first, 196t squared. 2 times first times second, 2 times 14t times 140. That's the square of the second one. Okay, now we get the chance to simplify. You see, you have these two together. You simplify it. So your function, s of t, would be this one. Okay, 196 and 196 would be 392. 392t squared. And you're going to minus 3,920t. Then the 49 and 196 added together, that give you this. So this is going to be your speed function. You want to know at what value of t this is a minimum. Instead of working with this function, you can differentiate it, okay? But instead of working with this function, you can square it and consider it a square function, because the value of the t would be the same, but the minimum would be different. But you are not interested in the minimum value. You are interested at the time, okay? So I've seen some people that just differentiate it right away. That's true, but this is the way I suggest. I suggest that introduce the function f of t to be s of t squared. So in this way, you get rid of that radical and straightforward, you can find it right away, okay? So if you square it, that gives you 392 t squared, 3,920 t. This is your function. See, it's easy function to handle. So find when this function is minimal. So differentiated, f prime of t is equal to just 2 times 39, 784 t. This would be 3,920, and the rest going to 0. Okay, you let it equal to the 0. Find the critical value. So 784 t minus 3,920 equal to the 0. So you solve for t. So your t would be, this is it, 784. In this case, the t is 5. So from language of the calculus 1, this is the critical value. Okay, but you have to confirm that you get the minimum. Okay, so you have to confirm that give you a minimum. F, you have 2 choices, the first derivative test and the second one. Of course, the second one is easier. You find f double prime concave up, remember? F double prime positive, the graph concave upward, you get the minimum. F double prime positive, concave downward, negative, downward. Just differentiate it again. So f double prime of t. That gives you 784. It's positive. Positive means up, minimum. Okay, so that's easy test to check. So we find out that S of t has a minimum when t is equal to the 5, whichever 5/5 seconds, whichever measurement that is given to you. Okay, since they ask only for the value of the t, so you better square it, get rid of that radical. You can do it with the radical, okay, but you have to use the chain rule and to get this one through. Okay, so when they ask for the minimum speed, this is the way you are going to do it. Okay, you know, your book they like it and they give you a couple of these problems. So the one that you're going to have is going to be straightforward. Okay, so this is going to be the idea of the okay, those physical interpretation of the derivative of the function. Okay, that's one. So check your lecture notes for the other way around. If r prime of t is given to you, are going to recover the r of t. Okay, I did one example for you. Unfortunately, we don't have it. So that is the case. Now the rest are going to be just limit, derivative, and integral. Okay, let's check a couple of them quickly. So to get to the arc length, so we get time to do it. So let's do it one from each just to remind you. So that would be limit. You give me one. Okay, find. You want to find the limit of r of t. Okay, in this case, t goes to infinity. So this is it, r of t. There is a misprint here. It must be a vector. So this is it, arc tan, which is the same as the tan inverse. Tan inverse of t, e to the negative 7t, and the ln t over t. That's it. So we are going to find the limit of each component separately, one by one, and the result is going to be a vector. Okay, so you may have to use some theorems from calculus 1. So the limit of the tan inverse of t when t goes to positive infinity is going to be the same as the tan inverse of infinity. You want to find an angle whose tangent is infinity. You know that that angle is pi half. That's the first one. Any question? The second one. You want to find the limit of e to the negative 7t. T goes to positive infinity. You switch it into the positive power, e to the 7t, t goes to infinity. If you substitute infinity, so that you 1 over infinity, which is 0. Okay, that's the second one. And the last one, you want to find the limit of ln t over t. T goes to infinity. This would be infinity over infinity, and you have to use the L'Hopital rule. Okay, you differentiate the top and the bottom, and then the substitute again. So this is it. The limit of ln t over t, t goes to infinity. So we go with the L'Hopital rule. We differentiate. Limit of ln t 1 over t, and this is 1. T goes to infinity. So that give a limit of 1 over t, t goes to infinity. Again, 1 over infinity, which is 0. That's it. So the answer of your limit is going to be the following vector. The vector, the first component 5/2, the second component 0, and the last component is 0. Okay, remember the answer must be a vector. A vector. Okay, you have another one, you have the solution, just check it. So this is going to be the case. That's number 12. Number 13 is again unit tangent vector. Just check the solution, you differentiate R prime of t and the norm. Let's check this integral to see how we're going to write it down. And then you have to do the arc length and the curvature. Okay, just give example of those as well. That's 12. Okay, so number 15, definite integral, give you 1. Okay, so part 1, you want to find this integral of e to the 5t times I, that's 8t times j, okay, plus ln of t times k d of t. That's 1. So we're going to integrate each one of them separately and just do the job. Definite integral, you can pick. We're going to have a constant function. So I'm going to take the first part, e to the 5t dt. You know that the exponential function never change. It would be e to the 5t again. And you have to divide by u prime, which is 5. So e to the 5t divided by 5. A constant, you may call it C1. That's the first one. Any question? The second one, straightforward, 8t dt. So that give 8t squared over 2 plus a constant, you may call it C2. To simplify, that give you 4t squared plus C2. So that's a second one. The third one is ln t dt. You know that you have to use integration by parts to find it. Okay, if you know it, you can write it down. We accept it, t ln t minus, okay, ln t minus a, t. But if you want to do it, u would be ln t, and the dv would be dt. So you have to differentiate this one, that give you 1 over t dt, and you integrate the other one, that give you t. So put them together. ln t dt is u times v, t ln t minus v du. V is t, and the du is 1 over t dt. So these two will cancel out. You get the 1. So t ln t minus integral of the dt, which is t ln t minus t plus C3. Okay, so just do one by one. So the final answer is going to be, it's going to be a vector. You can write on the vector form or just the one that's given to you. So there are the first component, e to the 5t over 5, C1. The second component 4t squared plus c2. And the last one, t ln t minus t plus c3. So that gives you the result. Again, the result must be a vector. If you don't like this notation, you do it ijk, but both of them are optional. You can pick any one. Okay, so very mild integration by parts, you may need it. Just be prepared for it. Okay, so that we did the notion of the integral. The second one is easy, you don't need any integration by parts. So I'm going to go to the arc length because these are the ones that sometimes it's going to be tricky. Okay, so let's explain number 18. Arc length. So this is going to be arc length formula L equal to the integral from A to B, the norm of the R prime of T dt, or the SP. Okay, to get this one, because you use the norm, so it's going to be kind of a square root. Just make sure that you know the algebra is all right. We try to see, we give you something that can be done. Okay, so let's try. The first one is an interesting one. Part 1. The function is r of t equal to the I plus t squared j plus t cubed. And you want to do it between t between 0 and 2. Okay, so get the derivative. You can write on in the component form. So this is it. R of t is 1 t squared t cubed. Differentiated. R prime of t is going to be 0, 2t, 3t squared. It's 1. You get the norm. Norm of R prime of t is going to be the square root of 0, 2t squared, and the 3t squared. Okay, so let's see what we are going to have. So that gives you a square root of 4t squared plus 9t to the 4. Okay, you have to simplify it. You cannot combine it together, but there is a nice factor t squared, which is very, very useful. So it's going to be t squared out, 4 plus 9t squared. Now you take it out, it's going to be radical t squared. Radical 4 plus 9t squared. Radical t squared would be t. You don't need absolute value because t is between 0 and 2. So it's a positive number. Okay, so that gives you t radical 4 plus 9t squared, which is very good because you want to integrate it. And your prime is already given to you. Any question? So the one that you're going to see on the test is either the inside one is a perfect square. You can get rid of the radical, or it's going to be of this type. Otherwise, you can't find that integral. Okay, it would be difficult. So be careful. Okay, there you are. So we go with the formula. This is it. The integral is from 0 to 2. And this is it. You have the t square root of 4 plus 9t squared dt. Okay, you know that. You change that radical into the 4 plus t squared to the 1/2, and your substitution give you the result right there. Okay, so it's going to be 0 to 2. And this is going to be t times 4 plus 9t squared to the negative half dt. You take this one to be u, you need the du, u prime. Du would be 18t. You already got the t here. So you better divide, multiply. You can do it, your substitution if you like, but that's easier to do it here. So I need an 18 inside. I divide the outside by 18, and I multiply the inside by 18. I rewrite it. That's the short way to do it. So that give it 18 t dt. So this is u, and this is d. I have u to the negative half. Integral of u to the negative half would be u to the 1/2 divided by 1/2. Okay, so it's equal to the 1/18 u 4 plus 9t squared negative 1/2 plus 1/2. This is going 1/2 divided by 1/2. Of course, this is from 0 to 2, going from 0 to 2. Reciprocal of the 1/2 would be 2, so that gives you 2/18. 2/18, 4 plus 9t squared from 0 to 2. So it's going to be 19, those numbers, 4 plus 9t squared from 0 to 2. Okay, you substitute and you get the of course, this is 1/2 and the 1/2. Okay. It's not a nice number, but you can use your calculator to find it. So this type of operation is important to be able to create the u prime. Otherwise, you can't do it. So this is the case. I think the one that I gave you on your extra point, this is the one that you get the, okay, you have a perfect square inside that radical. Just check it, and the one that you get it in the lecture. The second one is a kind of helix. It's easy. Okay, when you have sine and a cosine, that's the best case. Okay, any question? So and you do the arcing quite a lot at the end of the course. You have one type of integral, we call it the line integral. And the line integral is when you drive through the road, if you like. So you do this one quite a lot for all those integrations. Okay, and the part B is it's a kind of helix. So that's easy to handle. R of t is 2 sine t, 5t, and the 2 cosine t. This can be done, should be able to do it easily. Let's see. Okay, we get R prime of t, which is going to be 2 cosine t. That would be 5 minus 2 sine t. So this is going to be the case. Now get the norm. Norm of the R prime of t is going to be the square root of 2 cosine of t all squared, 5 squared, and then negative 2 sine of t all squared. So that would be done. It's a 4 cosine square of t. That's a 25. And that would be 4 sine square of the t. Okay, as you can see, 4 cosine and 4 sine together, that give you 4. Okay, these two. Factor of the 4 is going to be 4 times sine square plus cosine square, which is 1. So that gives a radical for plus 25. So it's a helix, it's easy. It's always, the arcing is going to be, the speed is going to be just a constant, and you just integrate it. Okay, so that's it. The arc length, this time 0 to pi. Radical 29. Okay, this is going to be simply radical 29t from 0 to pi. So it's a radical 29 pi. So you shouldn't have anything to worry about. This one. Okay, any question? So don't miss it, the arc length formula, and that just make sure that if you get something inside that square root, take care of it. Okay, and finally the curvature. We give one straightforward question on the curvature. Okay, the curve would be given to you, okay, R of t, and we ask directly for the curvature of that. Okay, this is it. Curvature. This is going to be the case for the curvature. Just use the standard formula to find it, which is K of T is equal to the norm. Okay. What is the formula? Norm of the, I think it's what R prime of T cross R double prime of T and divided by the norm of the R prime of T all cubed. Okay, so there is nothing like that maximum minimum that I talk about it. That was just for your information. So let's use the the standard formula that. Okay, so we give you one straightforward. It's two-dimensional, three-dimensional one. So let's try. What is this one? I try the part R of T equal to the T squared. Try this one. 2T ln T. Try this one. Okay, get those derivative first. R prime, R double prime. So R prime of T would be 2T, 2, 1 over T. That is R prime of T. You need the norm of the R prime of T. Because then we can find the norm of R prime of T. It's going to be the square root of 2T squared, 2 squared, and the 1 over T squared. So it would be 4T squared, 4 1 over T squared. Okay, you cannot put them together, you just leave it as is. So that will be the bottom. Write it down as okay, everything to the 1/2, and that will be 3/2. So we have to prepare the top. So that's R prime, we need R double prime. Okay, differentiate again. So R double prime of T is 2, 0. This would be negative 1 over T squared. The top bottom would be 0, bottom top. So that's R double prime. Get the cross product of the R prime of T cross R double prime. See, so what's going to be R prime of T cross R double prime of T. Determinant of the matrix. Okay, IJK, this is it, IJK. R prime is 2T, 2, 1 over T. Double prime, 2, 0, negative 1 over T. Okay, take care of this one, then the no. So it's going to be equal to I times. Eliminate the first row, first column. Matrix is this one. 2, 1 over T 0, cross multiply. So that gives you negative 2 over T squared minus 0. Okay, it's going to be minus J times. Eliminate first row, second column, matrix, 2T, 1 over T, cross multiply. You multiply these two together, that gives you negative 2T over T squared minus 2 over T. Okay, this is it. Then plus K times, we'll eliminate the first row, last column. So the matrix 2T times 0 would be 0 minus 4. Okay, so what we're going to have, this is going to be negative 2 over T squared I Over here, these two would cancel out. So we get negative 2 over t. Negative 2 over t would be negative 4, and there is a negative here, we get the positive. So it's going to be positive 4 over t g. And the last one, we get the negative 4k. Okay, that's going to be our prime of t time the cross r double prime. You have to find the norm, and then go back, substitute, and take here. Okay, get the norm. So that give you r prime of t cross r double prime of t. It's the square root of the number. Okay, negative t 2 over t squared plus 4 over t squared and negative 4. When it's not going to be number, it's not fun really. Sometimes they ask it, for at t equal to 1, t equal to 2, that makes better sense, but this is it. So square it and go back, substitute to get the final answer. Okay, so this is going to be the case. So this is 4 over t to the 4th, and that's going to be 16 over t squared, and the last one is going to be 16. Okay, this is the norm. Just rewrite it. You can't do much about it. You can, you can get the denominator simplified a little bit, and you have another t is coming from the other side. You may be able to do something about it. Okay, so basically this is it. So the denominator would be t to the 4th. It's not going to be getting anywhere. So that gives you 4 plus 16t squared plus 16t to the 4th. Okay. But again, it's not going to be a big deal because the other one is this one, and then you raise it to the, raise it to 3. Just to write it down as is really. So that gives you the final. Okay, so we go back and rewrite it. We get the k of t. Okay, so this is going to be the curvature. I'm not going to use it. Depends on what you want to do in future. Get these numbers done. Okay, so I think I did all the important one for you that you need to know. That's it. Any question? So 11 topics. I repeat it again. 4 from your quiz. So your quiz means you should be able to apply the cross product. Cross product as a definition of the area of a triangle. Triple product at the volume of that 3-dimensional solid that we talk about it. We are interested in orthogonal projection. Okay, the projection of the V onto W on the V, this type. Okay, the norm of the vector, this type of norm. I look at your quiz before before this weekend. So I grade it tomorrow for you. I grade it tomorrow morning, so I check to see if there is anything I should focus on. So because 4 questions from the quiz will be given to the rest, are going to be just the one that I did today. Okay. I can, if you just remind you that all the curvature that we have here are 3-dimensional. So we give it 3. You know that that function is going to be a function of 2 variables. Then you want to get r of t. You write the x, f of x, and 0. It's not going to be the case. So you shouldn't have any difficulty for these. Okay. So let's see. I can do one more for you. Case of the I did the limit, okay. I can check one of these tangent line with unit vectors, number 13. After time, I check one of them to see. It should be straightforward. So it's not a normal vector, so it's just a tangent vector. So number 13, unit vector. So we want to find the unit tangent vector. The normal one takes time, but we usually give you something very close to the helix, so you should be able to do it right away for us. Okay, so the first part, R of t is 25 over 3 t cubed, 25 t squared, and the 50 t. Okay, no numbers given to you because the one that we did, you asked to do it at t equal to 1, but not this one. No problem, we can do it. So remember that t of t is going to be just a tangent vector, which has been normalized. This is the formula. Okay, if the value is given to you, you can value that at the given number. So differentiate r prime of t is going to be equal to, so differentiate the derivative of t cubed with 3t squared, so that gives 25 t squared. The second one would be 50t, and the last one just 50. So that would be your derivative. Get the norm to normalize it. So if you want to normalize it, norm of the r prime of t is the square root of 25 t squared all squared, 50 t all squared, and the 50 squared. I don't think that it would be something to simplify. So it is going to be 625 t to the fourth. Okay, and that gives you 2500 t squared and 2500. The only thing that you can do is you can factor out the, okay, you can factor out the 25 to take it out, or maybe 625. 625 times 4, I think, 4, yeah, we can take 625 out. So it's going to be, if you factor out 625, so that gives you t to the 4th, and this is going to be 4t squared plus 4. Okay. So, and that's a perfect square, because that gives you 25, and the leftover is going to be t to the 4th, 4t squared plus 4. Okay, now this is a perfect square. So that gives you t squared plus 2 all squared. So this, especially for the arc length, this would be useful to know that. Okay, so we have to check. So in this case, the result would be 25 times t squared plus 2. So if you get a chance, you have to simplify it. This problem is going to be a good problem for the arc length. Okay, so this is it. Now we are ready to give you the t of t. This is a norm, okay? So a t of t is going to be r prime of t over the norm of the r prime of t. So it's r prime of t. The norm, you already got the 25 times t squared plus 2. So in vector form, this is what you're going to have. So it's going to be t of t equal to 1 over 25 times t squared plus 2. Now the vector. R prime, 25 t squared, 50t, and 50. You can simplify all of them by 25. Okay. So that gives you 2 and 2. So the result is 1 over t squared plus 2. Inside, you get the t squared, 2t and 2. So, that would be your unit vector, unit tangent vector, t squared over t squared plus 2, 2t over t squared plus 2, actually 2 over t squared plus 2. So that gives you the final answer. So if you get a chance, you have to simplify it. Okay, and that was a nice one. That's it. Any question? So again, you can take the test if you like at the APC starting tomorrow. Okay, tomorrow, Thursday and Friday, and otherwise Monday, see you here. Okay, if you are going to be here, we give you all the lecture hour. Okay, so we get 2.5 hours to be able to do it. And you should be able to do it. Okay, study whatever I did today, plus plus your quiz, and you should get 100% this one. Okay. When you're done with your test, you can forget it. We're not going to use it for the time being. We start it over. You go to the function of 2 variables, okay, and it's going to be new. But for the vector valued function, we come back to it at the end of it. We're not going to say it on this too. On the final, we need it for that final part, because the final will cover all the integrations. So this is your last chance with these ideas. Okay, that's it. So I grade your quiz tomorrow. I post the, okay, if I need, if you need, I post the solution for you.